Hello friends, today I am going to teach you how to draw shear force and bending moment diagram for a simply supported beam with concentrated load. That concentrated load is known as point load. Okay, this is the support reaction RA and RB, and concentrated load is act and the middle point of the beam section. Okay, first of all, I'll explain you the whole process of this video. Firstly, I am going to find out the RA and RB values. Then I want to find out the shear force and bending moment values for the selected length of the beam section. Okay. Then using those shear force and bending moment values, I can draw the shear force and bending moment diagram. Okay. Let's start our calculation. Before starting the calculation, I must say the sign convention. Okay, here's my sign convention: upward forces plus, downward forces minus, clockwise movement plus, anti-clockwise movement minus. Okay, these are the sign convention relevant to this problem. The given beam section is equilibrium, so I can consider upward forces minus downward forces is equal to 0. This is RA and RB are upward forces and 2 kN downward forces, so I can get the expression like this. Due to given beam section is equilibrium, the bending moment of any point is equal to 0. Okay, I can write like this. So I am going to get the moment from the RA. The first step is done. Then let's move on to our second step. My second step is I am going to find out the shear force and bending moment values for the selected beam sections. My first selected beam section is 0 to 3 meter. For more easier the problem, I can draw the section relevant to this range. Okay, this is the relevant beam section of this range. Okay, so I can according to sign convention I can write upward forces minus downward forces is equal to 0. So using this expression I can calculate the shear force for this range. Okay, this shear force is 1 kN. This should be understood properly. This 1 kN shear force is relevant to this range. Okay, this should be properly understood. Okay, then I am going to select my second beam section. This is the beam section relevant to the 3 to 6. Now I am going to find out the shear force. Okay, for that I am considering upward forces minus downward forces is equal to 0. Okay, I have already calculated shear force for each beam section. Okay, now I am going to find out the bending moment for each beam section. Okay, according to the sign convention, this is anti-clockwise bending moments. That's why here minus mark, and 1 into x means clockwise bending moment. So that's why this is positive. Now I have taken the expression with x. So I can substituting x as 0 and 3. I can get a value for bending moment. Okay, then I am considering my second beam section for finding the bending moment. Okay, I have already calculated the shear force and bending moment value for the whole beam section. Okay, now I am going to draw the shear force and bending moment diagram. Okay, first of all I want to draw the free body diagram of the given section of the beam. Then I will draw the two axes. Then I will mark the two axes and their units. Okay, firstly I will draw the shear force diagram. Here you can see the length between 0 to 3 meter. Along the beam section, the shear force is constant value. It is 1 kilonewton. So I can draw like this. According to my second range, the length between 3 to 6 meter along the beam, it is constant value. So it is minus 1 kilonewton. So I can draw like this. The area should be same. This area to this area should be same. Here 1 kilonewton. Here minus 1 kilonewton. And this point is 3 meter on the B. Here we have drawn the shear force diagram. Now I am going to draw the bending moment diagram. Okay. Here length between 0 to 3 meter along the beam section, the bending moment varying from 0 to 3 kilonewton meter. Okay. This is like y equal to mx. You know what is the shape of the y is equal to mx. When x is equal to 0, the bending moment is equal to 0. And also when x is equal to 3, the bending moment is 3 kilonewton meter. Okay. This shape should be y is equal to mx. In the second beam section, the length between 3 to 6 meter along the beam section, the bending moment is varying from 3 kilonewton meter to 0. Okay. This bending moment expression I can rearrange into y is equal to minus x plus c. We know this shape is angle line with negative gradient. Okay. Okay, this is 0, this is 3 meter, this is 6 meter, and this value is 3 kilonewton meter. Okay. Here there are two things I want to say. First one is the starting point of the bending moment and the ending point of the bending moment is 0. Apart from that, the maximum bending moment indicates when the shear force is equal to 0. Okay. These are the special things I wanted to say. So I hope this is very useful for your some kind of problems relevant to this. So thank you.